Hey guys, today I'll be talking about carbon laser peels. The Q-switch laser is the optimum laser for performing carbon laser peels. The main absorptive chromophore for the 1064 nanometer Nd:YAG laser is melanin located in the epidermis. However, this wavelength weakly absorbs laser energy. Aside from melanin, there is no particularly strong chromophore in the skin. What is a carbon laser peel? Carbon laser peels involve applying a topical carbon suspension to the skin to act as an exogenous chromophore absorbing light energy emitted from the Nd:YAG laser. Carbon solutions are comprised of purified carbon particles in a mineral oil base. Nd:YAG light energy is absorbed well by carbon in comparison to other cutaneous chromophores, including melanin. The particles are activated by the light energy and rapidly rise in temperature, leading to heating and removal of the stratum corneum. The quasi-long pulse Nd:YAG laser has a pulse duration of 300 microseconds compared to the 5 nanosecond pulse duration of the Q-switched Nd:YAG laser. The degree of dermal coagulation depth is dependent on the pulse duration. Quasi-long pulsed laser beam penetrates deep within the dermis, whereas Q-switched reaches just the superficial dermis. Therefore, the 1064 Nd:YAG laser is an effective treatment for decreasing sebum levels and pore size. Carbon laser peel procedures. The carbon suspension is massaged onto the treatment area and left on for 20 minutes prior to treatment to allow absorption into the skin. The extra carbon solution is removed. The carbon particle provides a film over the stratum corneum, and the remaining carbon particles are lodged in enlarged pores and follicles. Carbon particles rapidly rise in temperature when they absorb high peak powers of laser energy in an ultra-short pulse, for instance 5 nanoseconds, with extremely high photon intensity in the milliwatts range. This rise in temperature leads to photomechanical destruction of carbon particles, which means the laser blasts the particles off the skin. The kinetic energy produced causes destruction to the stratum corneum, inner walls of pores, and nearby structures, leading to skin rejuvenation and tighter pores. Following treatment, sebum levels are also reduced, and this is proposed to be due to the decrease in pore size. So here's just a quick clip of what a laser carbon peel looks like. Benefits. The 1064 Nd:YAG laser can be used to reduce the development of rhytides. Histological findings have revealed that the Nd:YAG laser generates effects in the reticular dermis with increased collagen synthesis. Increased collagen synthesis in the reticular dermis or superficial papillary dermis could subsequently lead to reduction in pore size, particularly as a result of perifollicular collagen production. Microsecond Nd:YAG lasers with the same pulse duration to the micropulsed Nd:YAG laser mode also have the ability to generate new collagen production in the papillary dermis. Nd:YAG laser using micropulsed and Q-switch modes produces greater improvements. Quasi-long pulsed Nd:YAG laser has a pulse duration of 300 microseconds compared to 5 nanoseconds with the Q-switched Nd:YAG laser. Different tissue reactions were observed as two pulse durations were operated. Application with the micropulse mode generated a photothermal effect with the addition of the carbon solution, which acted as a photoenhancer, producing heat shock proteins deep within the dermis. An explosive radiant heat effect occurred afterwards with photoacoustic and photoosmotic reactions causing stratum corneum and pore wall destruction. A photothermal effect is generated with micropulsed laser beam, which is produced by the heated carbon particles within the deep dermis compared to the Q-switched mode, which triggers the explosion and removal of carbon particles.